This video is on solving quadratic inequalities. So in the 3 previous videos, we went over examples, and this will be the 4th example here, using these steps here. So the first step is we're going to go ahead and solve this as if it was an equation. So we're going to do 2x squared plus 5x equals 12. So we want to know what numbers will make it equal 12, not less than 12. So that's the first step. So when we solve this equation here, this whole chapter has been on, one of the big focuses has been on solving equations with exponents that are quadratic. So to solve this, I'm going to go ahead and subtract 12. I want to make it equal 0 so that I could either choose to factor or use the quadratic formula. So if I want to factor, I have to think of what multiplies to negative 24 and adds to 5. But because the previous 3 videos in this section I have done factoring, I'm going to go ahead and use the quadratic formula. So remember, the quadratic formula is negative b plus or minus b squared minus 4ac all over 2a. So that's the formula that I'm going to use, and we can use it anytime we have an exponent of 2 and it equals 0. So negative b plus or minus b squared minus 4ac all over 2a. So we're going to go ahead and simplify. 5 squared is 25. Negative times a negative is a positive. And then we have 4 times 2, or negative 4 times 2 times negative 12. And that is 96. So positive 96 all over 4. So 25 plus 96 is 121. Okay, then the square root of 121. So what times itself is 121? That's 11. So negative 5 plus or minus 11 over 4. Whenever the radical goes away, just as a review, it means this was factorable. So when there's no radical here, we could have factored it instead. So then we have negative 5 plus 11 divided by 4. And we have, negative 5 minus 11 divided by 4. So negative 5 plus 11 is 6 over 4. And then if we simplify that, divide them both by 2, we get 3 halves. And then here we would have negative 16 divided by 4, which is negative 4. So we get 3 halves and negative 4. So remember, these two numbers here, if you plug them in, make it equal 12. Well, it doesn't have the line underneath. So step 2 is we are going to make a number line and put these two numbers that we just got on the number line. So I'm going to go ahead and make step 2. I'm going to make a number line. Negatives are always smaller, so it goes first. And then I'm going to put the 3 halves here. And I'm going to put 2 open circles here. And again, this means I'm going to use parentheses. Okay, so I'm going to use, this is an E right here, I'm going to use parentheses here. I'm going to use parentheses here because these two numbers make it equal, and it doesn't have the line underneath, so it means we don't want them to equal. Okay, so now I'm going to pick step 3. Choose any numbers in each that you want from each region. So I'm going to pick any number bigger than 3 halves. So if you don't really know what 3 halves is, 3 divided by 2. 3 halves is 1.5. So pick whatever number you want that's greater than 1.5. So I'm going to go ahead and I will pick 2 sounds good. So I'm going to pick 2. And then I'm going to pick any number in between -4 and 1.5. So I'm going to go ahead and pick 1. I can pick 0. I can pick -3, -2. And then pick any number less than -4. So I'm going to go ahead and pick -5. Okay, so that was step 2. Or step 3. Step 4 is to plug those numbers into the original problem. So step number 4, I'm going to take 2x squared plus 5x less than 12. That was our original problem. And I'm going to plug in -5 for x. So -5 squared is 25. And 25 times 2 is 50. And then 5 times -5 here is -25. 50 minus 25 is 25. And 25 is not less than 12. So no, this does not work. So we are not going to shade the values over here. Okay, so now we're going to do it again. And I'm going to go ahead and plug in 1 for x. And again, if you don't like 1, don't pick 1. So I'm going to do 1 squared, which is 1. And then 2 times 1 is 2. I'm going to plug in a 1 here. So 5 times 1 is 5. And we get 7 is less than 12. And that is a yes, that's true. So then I'm going to shade everything in between there. And then lastly, we're going to go ahead and plug in our last number here. And I have picked 2. I could pick 1,000 if I want. Any number bigger than 3 halves. So I'm going to go ahead and plug in 2. And 2 squared is 4. Times the 2 is 8. And then 5 times 2 is 10. And 18 is less than 12, or is not less than 12. So this is not true. So we're not going to shade here. And then our final step, step 5, is to write our answer from left to right as an interval, in interval notation. So from the left, it starts at -4. Parentheses, because there's no line underneath here. And then it stops at 3 halves, and parentheses again because there's no line here. So that would be our final answer. Any number in between will always make this side less than 12. Now if we take a look at that on a graph. Okay, so I went ahead and graphed 2x squared plus 5x minus 12 right here. And if I click on here, you can see the -4. And then if I click right here, you could see the 1.5, so the 3 halves, and it says less. So if we look at this graph, it is less in between here. The graph goes below the x-axis in between the -4 and 3 halves. It goes below because it goes above from -infinity to -4, and it goes above from 3 halves to positive infinity. So that's what it would look like on a graph. It goes below in between these. And it said below. That's what we were looking for.